Hey guys, let's do a physics problem. Alright, question 1. Earth is approximately a sphere of radius 6.37 times 10 to the 6th meters. What are a circumference in kilometers, its surface area in kilometers, square kilometers, and its volume in cubic kilometers? Alright, so this is a pretty easy first problem. In this problem, we're given the radius of the Earth, and we're asked to compute its circumference, its surface area, and its volume. Now, something that's important to notice, and it should be the first thing that catches your eye, in fact, that the radius we're given is in meters. However, we're asked every part of the problem asks us to solve for kilometers in some way. Well, square kilometers, cubic kilometers, but it all comes back to kilometers in some way. So that means we'll have to do a conversion at some point. Now, technically, well, in theory, you could do this either way. You could convert to kilometers first and then do each of the calculations to circumference and surface area and yada yada yada. Or you could do the calculations to each of these parts first and then convert later. However, my personal recommendation is going to be to convert to kilometers right away, because with the way the dimensions work out, with the whole squared kilometers and cubic kilometers, it can get a little tricky. That still isn't like hard or anything, but it's a little bit tricky. So I'm going to go with the easier method, which is just to convert it to kilometers right from the start. So how are we going to do that? Well, as I'm sure, I hope you know, there are 1,000 meters in a kilometer. So therefore, 1 meter is going to be equal to, and I'm going to add the 1 times just for the sake of the order of magnitude, is equal to 1 times 10 to the negative 3 kilometers. So that is our little unit, or little order of magnitude conversion there. So 1 meter is going to be 1 times 10 to the negative 3rd kilometers. And you know it's going to be negative because, well, if you have a meter, then it's going to be a very small amount of kilometers because there aren't even 1,000 meters here. So you can use that to help you, I guess. But the point of the matter is, this is the conversion here. So we're going to want to take effect of this. So because we have a negative 3 order of magnitude, and we're trying to convert that by a 10 to the positive 6th order of magnitude, we're just simply going to take 3 away from 6. It's going to be basically a 6 minus 3 thing. Think of it like multiplication, where it's 10 to the 6th times 10 to the negative 3, where all you're really doing is just subtracting the exponents from each other. So our radius here then, let's call it r sub e, is going to be 6.37 times 10 to the 3rd kilometers. And by the way, yes, I'm aware that the handwriting is a little bit bad. I'm writing with a mouse, so it's a little tricky. But as long as you can hear and understand what I'm saying, it shouldn't be too bad. Besides, I'll probably get better as time goes on, so that's neat. That's good anyway. But for part A, though, we're asked to find the circumference in kilometers. So now that we have it in kilometers, all it is a matter of a simple conversion. So if you don't know already, the circumference based by its radius, the circumference of a sphere or circle based on its radius is equal to the circumference equal to 2 pi r, the radius, which in our case is r sub e. Now this is something, it would be very good to know this offhand by heart, because with problems like this, especially in physics and such, it comes up a lot, so it'll be good to know that, to have this memorized. It's pretty simple though, so it shouldn't be too hard to memorize, but just try to get it known. So we're going to sub in our values then, so it's going to be 2 pi 6.37 times 10 to the 3rd kilometers. And if you plug this into a calculator, the answer you get is going to be about equal to 4.00 times 10 to the 4 kilometers. Now, the 4.00 thing, I am rounding a little bit. You get a slightly more specific, a slightly more precise value if you plug it into your calculator. But I'm not going to worry about that because when we're dealing with problems on a planetary scale like this, it's usually a better idea not to be too precise because usually our values aren't very precise to begin with. In this case, for instance, we're given 6.37 to the times 10 to the 6th. So we're only given 3 significant figures to begin with. So it's fitting that I'm going to round to 3 significant figures, which is why I included a 0.00. Anyways, though, let's move on to part B, where we're asked to find the surface area in squared kilometers, which is an important detail right there. But how do we find the surface area? Now, another important math, geometry, whatever you like to call it, a formula, that the surface area of a sphere is equal to 4 times pi times the radius squared. So that's r sub e squared. Now, it might also be a good idea to memorize that one, though it's not used as commonly, so maybe you won't have to worry about it as much. So 4 times pi times, and let's just once again plug in our little radius. So 6.37 times 10 to the 3rd kilometers. And don't forget the square, by the way. That's a common mistake, or at least I do it a lot, where once you write out the little order of magnitude, you're including an exponent. You have to the power of 3. You're already writing that in. So you might write that in and then forget the fact that you actually have another exponent to write on the outside as well. So don't forget the square. That's very important. And so plugging all this into your calculator gets you about 5.10 times 10 to the power of 8. 8 kilometers squared. And that's another important thing to keep in mind. The unit is squared as well, because we're dealing with area rather than a simple length. So it's going to be kilometers squared. And once again, I rounded to 3 significant figures. And for our final part, what is the volume in kilometers? Cubic kilometers, rather. So the formula for the volume of a sphere, and of course we are approximating Earth as a sphere. I know someone's going to point out, oh, well, technically the Earth isn't a perfect sphere, but we're going to approximate it anyway. That's why I'm rounding to these significant figures. But the formula for volume of a sphere is 4 over 3 times pi times the radius cubed this time. Noticing a pattern here, wherever it says, oh, we need squared kilometers, it's going to be the r squared, or whenever you need cubic kilometers, it's going to be r cubed. And there's a little connection there that's important to be aware of. So alright, let's plug in our values now. So it's 4 pi divided by 3 times our radius. So that's 6.37 times 10 to the 3rd kilometers. And it's all under a cube. And so the value we get for plugging this in is about, in 3 sig figs once again, 1.08 times 10 to the power of 12 kilometers cubed. All right. There we go. And so that is the answer for all 3 of our parts to that problem. Now, this is the first problem in the textbook. So the little textbook I have open right here. And there are a lot more problems to get through. So, let's wish ourselves luck on this journey.